Hi.
Hi, are you sure this course is just for.
Hi.
Hi, are you sure this course is just for 2499?
Yes. And you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes. Sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Channel Geeks for Geeks Practice. This is Abhinav and today we day which is easy task. Hi Risit, hi Akar. First of all, please let me know that I'm clearly audible and start. Hi guys, hello. Great, will do you all so that we can start. Audio is breaking. I hope it should be fine now. Hello. Hello. Am I audible now? I hope it should be fine now. Okay. Great. Thanks. Yeah. So the problem today is yeah. Hi Manak. Hi guys. Hi. Okay. Great. So the problem today is easy task. It's a really tough problem for those who don't know about segment trees. So the prerequisite of this problem is segment trees. By the way, I will give you the quiet introduction of how what segment trees are. But then also you have to have some knowledge of it before that because I cannot have the complete segment tree explanation in this class. Okay. In the last week, if you remember, we were having a problem on tries. Okay, which was again an advanced ASA topic, and again today we have a segment tree. So yeah, nowadays the PODs are becoming very hard. Great. So let's start today's class. Let me share the screen, guys. I was getting daily. Okay, let me share the screen, guys, and let's start our today's problem of the day. I hope that my screen is completely visible to you all. So, guys, the problem is simply update and query problem is there. The basic problem for which segment tree is defined actually. Okay, the problem says that you are given a string whose length is n and array queries of length. So basically, there are two queries. One is a update query, and one is a query where you have to find the particular lexical smallest character, largest character. Sorry. So the first type of query is that basically you are given a index and a character. So you have to change that particular index with that new character. That's the first query. The second query is simple, that you are having a left and a right, and between that two indices, left and right, you have to print the kth lexicographically largest character. Okay, that is what you have to do. So maybe Manak, you are having TLE because you are using a simple brute force approach. But guys, simple brute force approach is not possible here. Okay, because it's a query based problem and updation is also there. So in these type of problems, we mostly take use of segment trees. Okay. So for those who are not having a pre-knowledge of segment trees, I will have a quick introduction of it. But you have to, it's needed for you to first go through that. Okay. So I hope guys that the problem is now clear to you all. Okay, so let me first give you an introduction of what is segment trees. So guys, segment trees is just like a binary tree. Okay, it's just like a binary tree. And what happens in segment tree, uh, what happens is that your string or your array is basically divided into a segments, and which makes it easy to do query related works. So let's say that your string has a size of 6. So means from 0 to 5, it will be here. From 0 index to 5 index, it will be at the first. Now from 0 to 2, it will be here. 3 to 5, it will be here. And this is how, guys, your indexes are divided into some segments. And then your queries are placed on that segment. Okay, no, Manak, like that is also not correct. Priority queue. This is a pure classical problem of segment tree. This cannot be solved using any other logistics in an effective way. Okay. So now, guys, you can see I'm creating a segment tree out of the string which is given to us. So as I'm having a string, what I'm doing is that out of the given string given to us, what I'm having, I am creating a segment tree, and every segment tree has an array of size 26. Every node of a segment tree has an array of size 26. And guys, 26 why? Because we are having characters here. And that array will store the kth lexicographically largest characters in a sorted manner. They will store the characters in a sorted manner from the left to the right index. Okay. So that is how we are building the segment tree. For update, what we are doing, guys? Let's say we have to update the index number position with a new value. So first of all, what I'm doing is that first of all, I'm going to that particular position. So how we move to the particular position? Let's say, guys, that I have to update position number 3. I have to update position number 3. So initially I will be at index number here. So this is the root node. Now you will first find that 3 is whether greater than its middle or it is less than its middle. Because all the values from 0 to middle are at the from 0 to mid minus 1. So you can see if this is the root having values from 0 to n minus 1. So values from 0 to mid minus 1 go here, and values, I think not mid minus 1 mostly, the values from 0 to mid goes here, and values from mid plus 1 to n minus 1 goes here. Or if I'm simply saying if the root node is having L comma R, so we find the mid as L plus R by 2. So the left subtree has L to mid, and the right subtree has mid plus 1 to R. So for those who have the knowledge of segment tree, this would have familiar with this thing. Okay. Now, what I'm having here is also, first of all, I am finding the position of that index. So let's say I have to update index number 3. So I'll first go through index number 3. So like I will first have 0,5. From here, I will see that its middle is 2, means 3 will be at the right of it. I will go here. Now its middle is 4. So it means 3 will be at the left side. Now 3 will be at the again left side, here will be 3. And now I will reach that particular node 3 and I will update my character like this. This is the update query that I am doing. Okay. Similarly, guys, the query that we have, in the query what we have, the query wants from us every node of my segment tree, what it is storing. So as I told you that every node of my segment tree, it is storing an array of size 26 which contains all the characters in lexicographically manner. So whenever I will call for this query, it will give me an array or a vector of size 26 having all the characters arranged in a lexicographically manner. And then out of all that characters, I will return the kth largest character. So let's say that the vector that I'm having is like this. Okay. Uh, just a minute. Yeah. So now what will happen is in this particular array, the characters will be arranged in a lexicographically smallest order. Let's say first there is Y, then P, then D, C, C. Let's say we want the third lexicographically smallest character. Hello, Naka Chalo. So what I will do, I will iterate through this string and I will find the third character, which is D, which is the lexicographically smallest. Okay, which is the lexicographically smallest. And for every character, I will do this thing. Every character is how many times? Okay. Something similar to this we will opt in. Okay. So guys, what we will do here is that we are having the string, we are having the vector, we are having the queries. So I will take the string and for every query, I will perform this particular operation. Okay. And before it, guys, you can see that I have already taken a 2D vector here of segment tree. Okay. With which we will create a segment tree. And for better case, guys, what do we do? We take our segment tree in some multiples of our string. Okay, so as you can see that our string is having size n. So let's take the segment tree as like resize this vector. Let's resize this 2D vector with 4 into n so that any upper bound is taken. Okay. Now for every array, because it is 2D vector, it is a 2D vector. And as I told you, every node of the segment tree will have an array of 26. As I told you, every node of segment tree will have an array of 26. So means in every node of the segment tree, I will resize it to the value 26. Okay? Okay? Yes, your reset we will have a dry run. We will have a dry run. First, let's implement it. Okay? Great. Wait, let me see if okay, let me see if I can have an image where already a segment tree is created. Then it will be easy for me to define. Because if image is not there, then I have to create my own segment tree, which is going to be very complex, obviously. Let me tell you the segment tree in a string image. Okay, by the way, string image is not given here, guys. Image is not given here. Let me check. Let me create a segment tree for you all. Okay. So guys, let's say string that we're having is AB. Okay. So like the string that we're having is AB, which is of size 4. Which is of size 4. Now my segment tree initially, okay, is like actual thing is that every segment tree has an array of 26. Let me try to draw it. Let me try to draw it. Like this is a, let's say, a first root node which has an array of size 26. uh, let's assume it's the size of 26. Okay, and the range of this node is 0 to 3. Now from this, its middle will be 2, its middle will be 1. So first node with 0 to 1 and second node with 2 to 3 will be taken, and they both will have their own. Now this is how your segment tree will be there. I hope it is. I hope like it's quite complex, uh, but yeah, this is how a segment tree is there. If we take 8 in place of 4, yes, but Manak, like it will not take much difference. Okay, it will not take much difference for 8 and 4. Okay, only the space complexity difference is there, which is also constant. Even if you take 4 or even if you take 8, both are constant. Log 8, log 4, everything is constant. Like I'm not taking any variable. Okay, like this stream. Okay, yeah. Now every has its own. Now, guys, when I'm building is for every segment tree, I'm making its character plus plus. So see you can see here, my string was AB. So let's say this is 0, 1, 2, 3, 4, 5, 6. This is also 0, 1, 2, 3, 4, up to 25. Okay, up to 25. But because it's a better thing that here we only have A and B, so we just need 0 and 1. Okay, else will be 0. So because you can see guys, from index number 0 to index number 3, how many A's we have? How many A's we have? So we have 2 A's. Then how many B's we have? We have 2 B's. We have 2A, 2B. From 0 to 1, we have 1A, 1B. From 2 to 3, we have 1A, 1B. From 0 to 0, we have 1A. 1 to 1, we have 1B, 1A, and 1B. So this is how your whole destruction will. Okay? Is it clear? Is it clear how it will be done? How the segment tree is created? That is how the segment tree is created. Every node has its own array, and it is storing how many times a number is appearing. So when we have to update, let's say I'm again making here a. So when I'm updating, that node will go at that particular point. It will decrease for B. It is, you can see it is decreasing for B, the current node, and it is increasing for that value which are having. Okay. Now let's say I have to find the answer for 0 to 1. Okay, from 0 to 1 is the kth longest, and let's say k is equal to 2. You want the kth largest element. So when I want 0 to 2, so this particular vector will be written. Okay, this particular vector will be written. Got it? And then from it, I can simply check ki fine. Like A is having one time, B is also having one time. So means my output will be B. Let's say I'm saying from 0 to 2. Now I want from 0 to 2. So when I'm having 0 to 2, so it will add my two vectors. It will have the vector from 0 to 1, which is this one. And it will have vector from 1 to. So this is from 0 to 1 and 1 to 2, which is this. It will add these both the vectors. You will see the update query, they are adding both the values. They are adding the value of, okay, you can see they're adding the value of AI, A1 and A2. So these two will be added, and finally the final vector will be like this. Means there are two A's and one B in this value. You can see there are two A's and one B between 0 to 2. And now from this two A's and one B, I will check. So first I will check for all the A's, then I will check all the B's, and then finally when I will get kth largest, I will print it. Yeah, man, like that will affect. Obviously, that will affect. Okay, that will obviously affect. I know. Fine. I hope now it should be quite clear to you all. So now we are having segment tree. Now guys, I will first build my tree. So using the build tree function that we are having, I will build my segment tree with the string s. Initially, the values will be 0 and -1. Okay. Now to store my answer, I will have a vector answer. Okay, I will have a vector answer. Now what I will do, guys, now I will check for each and every query. Like there are like in Q queries are there. So for every Q query, I will move. Okay. Now, guys, if my query is of type 1, if my query is of type 1, so I will simply take the index that I have to update. I will simply take the index that I have to update. And because it is an integer, I will like it is in a string. So I will convert my it is integer because you can see that queries have the values in a string. Okay. So I will convert that string into the integer using the stui function. Okay. And then guys, I will have the value that I have to update. I will have the value that I have to update. Like this. Now I have to simply update the value at this index to this new value. So for that, I will call my update problem with initial at 0, 0, n minus 1, whole string, index is given and values. This is how I am updating. This is how I am updating. Now, guys, the second query is where we have the value of L, R, and K. You can see in the second query we have the value of L, left, right, and K. So let's have the values of that. Okay. So for that also we will use the stoi function. Okay. So like my left will be nothing but the first index. My right will be nothing but the second index, and K will be nothing but the third index. Now guys, using the query function, I will find this string. The string which will have the number of characters in that particular substring. Number of characters in that particular substring. Because these nodes are just storing the number of characters. So this array it will give us. This particular array. The array which will tell us the number of characters and their frequency present in that array. Like let's say I'm saying for from 0 to 2, there are 2 A's present and 1 B present. That it will tell me. Okay, so I'll have that vector here. So let's say now let's name it vector ARR, and I will call here the query function, which will return us the value or the characters present between L and R. Now guys, now what we want. Okay, now guys, you can see one thing that now I have to iterate through this array. So first I will iterate through this first. See guys, what we have to do is that let's say I want the kth largest. The kth largest. Okay. And k is 1. So my answer will be A. If k is 2, then also my answer will be A. Oh, sorry. Oh, it's not A. It's not A. Because guys, it should be like this. It should be like this. C, D, E, F up to Z. So we want the lexicographically longest. Now, okay. So we want lexicographically longest. Means I will check from the back. We want lexicographically largest string. Sorry. So I will check from the back. Okay. So let's say my K is 1. Means I want the first lexicographically longest. So my answer will be B. Why B? Because from the back you will see the first string that you're having is B. Now when K will be 2, so B is gone, A will come. When it is 3, again A is the answer. Again A is the answer. So I will have my loop from the back side, from the J. Okay, so I will have my loop from the back side 25. Okay, and then for every value I will find how many times it's present. So for every value, I will find how many times it's present, like this, like this. Okay. And every time I will skip one value. So let's say I want my k is equal to 2. Means I want second largest lexicographically. So I'll first come to 0, 0, 0, nothing. Now I got a b. Now I got that there is one b present here. That is the lexicographically largest character in the whole. You can see in the whole is substring from a like 0 to 2, which is ABA. B is the most lexicographically largest which is present. But we want, let's say, a value of case 2. So we don't want the first lexicography scholars. We want the second lexicography largest number. So when I will got my first lexicography scholar, I will decrease my value of k. And if my k will become equal to 0, means I have got the k lexicography locus. Then I will push it back into my answer. Then I will push the character present at my jth index. So a plus j. I will say. Okay, that is what guys we will do. And then at the last I will return my answer. uh, I think there's some problem happened. I think after pushing it we will also break. There's no need to then check. Yeah, let me first figure out what's the problem here. Okay. Okay, I have to return this answer after my. Okay, I have to return this answer at the last. That's the problem I'm having. Okay, that's the problem that I have. Again, wait. Now it is like fine. I'm also breaking. Okay, I'm breaking it from this loop, but I'm not breaking it from the another loop. Hmm. Is anyone getting what's the problem we're having? Okay. Here, my value is a character, guys. This value is a character. It's not a. Okay, this value is a character. It's not a integer data type. Got it. It's a character, and we just want its first. Okay, now I think we got it. I think so. I've taken value in integer, but value is a character. Yeah. Now it's done. Let's check it. Yeah. So you can see that all traces are passed. So like guys, this is the very basic problem of direct problem of segment tree. Okay. You can see it has taken from us half an hour to do this problem. It was a really hard problem. It was not medium. It was a hard problem, by the way, for a beginner actually. Okay. You can see the time complex is exactly same what is written here. Okay, because for every because there are q queries and every query in segment tree takes log of n times. Okay, and for building segment tree, it's take order of n. So this is the time complexity, and space complex is also guys order of n. By the way, it will be order of 4 into n into 26. Our space complex should be order of 4 into n into 26, but because we don't consider constants, it's simply order of n. Okay. I hope, guys, that you have got this particular problem. It's a really tough problem, I know. But for those who don't know segment tree, you can have a revision of it, then you will for sure get it. And I hope it is got. Okay, great. So, okay, so you're having a debate in the chat box. Do you think increasing children will? Okay. Okay, let's see, guys. Okay, so that's all from my side today. Let's meet again tomorrow with a new problem of the day. Till then, thank you. Happy coding. Uh, all the best for today's beauty. GFG कर लो हो जाएगा.